This is a video from section 12.4 in a Calculus 3 class. Let's take a look at problem 28. It says, find the area of the parallelogram with vertices P, which is the point 102, Q, which is the point 333, R, which is the point 758, and S, which is the point 527. All right, let's draw a picture of a parallelogram. So here's P, here's Q, right? And I'm going to connect P to Q. Here's R. And this point here we'll call S. Okay. Now, from here, I want to form the vector PQ. And I want to form the vector PS, like so. Okay? Now, PQ is the vector 2, 3, 1. PS is the vector, this is 4, 2, 5. Now, if I take the cross product of PQ with PS and then take its magnitude, that will give me the area of this parallelogram. So, in other words, I'm going to take the cross product of PQ with PS. Now, the first component is 15 minus 2, 13. The second component is negative 6, right? I took 10 minus 4, right? And then took the opposite sign because it's the second component there. And then the third component will be 4 minus 12, which is negative 8. Now, the area is the magnitude of PQ cross PS. But this is the square root of 169 plus 36 plus 64. Now, 64 plus 36 is 100, and then 100 plus 169 is 269. And so the area turns out to be the square root of 269. Now, I want to show you something a little interesting here, geometrically speaking. So here's P, right? Here's Q. We'll call this guy R, right? So if I draw a picture here, and I can call this guy S. And that's still a parallelogram. So this was just a visual of what a parallelogram looks like, right? I'm not guaranteeing that the vertices are going to appear in this order. But I claim geometrically we're going to get the same answer if the parallelogram looks something like this. And I want to go over that. Now, the vector PQ, okay? Now, if we go back, right, PQ is the vector 2, 3, 1. Now, I want to look at the vector PR. Now, PR is going to be 6, 5, 6, this vector. So if I take the cross product of PQ with PR, what do I get? Well, I'm going to get 13, -6, and then 10 minus 18 is -8. And so the area is the magnitude of PQ cross PR. Okay? And so this is the square root of 169 plus 36 plus 64. And if you notice, we got the square root of 269. And it was exactly the same answer. Now, with that, let's take a look at problem 29. What I want to do is I want to let P equal the point 311. I want to let Q equal the point 524. And I want to let R equal the point 853. Okay? Now, what is PQ? PQ is the vector 213. PR, that's the vector 542. So if I take the cross product of PQ with PR, what do I get? I get the vector -10. Now, 4 minus 15 is -11, but the opposite sign is 11. And then 8 minus 5 is 3. Now, the vector so the vector -10, 11, 3 is orthogonal to the plane through points P, Q, and R. Okay. Now, the second part of this question is really interesting. Okay. So now we want the area of triangle PQR. Now, I want to draw a picture for you guys. Here's P, here's Q, here's R, suppose, okay? We have a triangle. Now, do we agree this is half a parallelogram? Now, let me show you. Because I can extend this out, and I'll be darned, we have a parallelogram. So a triangle is half a parallelogram, so the area of the triangle is half the area of the parallelogram. So the area is 1/2 the magnitude of PQ cross PR. But this is 1/2 the magnitude of the vector -10, 11, 3. So this is 1/2 times the square root of 100 plus 121 plus 9. And so, therefore, the area of triangle PQR is 1/2 times the square root of 230. And that's how we do problem number 29. So let's take a look at problem 31. Same idea. I'm going to let P equal the point 7, negative 2, 0. Q equal the point 3, 1, 3. And then R equal the point 4, negative 4, 2. And so we want to find a vector orthogonal to the plane through points P, Q, and R. So I can write that down if we need. We want a non-zero vector orthogonal to the plane through points P, Q, and R. Well, we could always form vectors, right? So if we're given 3 points, here's P, here's Q, here's R. I'm going to form the vector PQ and form the vector PR. So PQ is the vector negative 4, 3, 3. PR is the vector negative 3, negative 2, 2. So PQ cross PR. This is the vector. 6 minus a negative 6 is 12. Okay, so I'm going to put a 12 in the first component. And then negative 8 minus a negative 9 is 1, but we take the opposite sign. So negative 1. And then 8 minus negative 9 is 17. Like so. So remember, 12, negative 1, 17 is a vector orthogonal perpendicular, right, to the plane through points P, Q, and R. Right now, so I want the area of triangle PQR. But this is 1/2 the magnitude of 12, negative 1, 17. Okay? So this is 1/2 the square root of 144 plus 1 plus 289, right? And this is 1/2 times the square root of. And then we're going to take 145 plus 289. So if we take 145 plus 289, I get 434. Now, the question is, will that reduce? And I would submit the answer is that's not going to reduce much at all. And so I would leave this alone. And that's going to do it for this video. This is a video from section 12.4, and we looked at problems 28, 29, and 31. Okay, thank you.